celebrating.
Yeah. Oh, wow.
I think 2 people died. I forgot they evacuated the plant well in advance when things started catching on fire.
Wow, that thing's gonna be loud. It's gonna be celebrating.
I think these guys were the plant workers here. Then I think nobody's there.
Where was this?
Nevada. Yeah, perchlorate's not so happy.
Do you think chlorine's happy in being, what is it, plus? What's that? Plus.
It's just plus.
No, it's plus.
What's the max on chlorine? Yeah, this is +7. So I was talking about this. Remember I was talking about chloride? Earlier I was talking, chloride, is it happy or not happy? Chloride is happy. You know, you take table salt, no big deal, right? No big deal. But if you eat this stuff, you're in for unhappiness because chlorine, although don't eat this, but if you eat this stuff, you're in for some unhappiness because chlorine is plus, no. We just did this one earlier. Plus, no, +5. Not as unhappy as this, but unhappy.
And so you're in for some nastiness if you eat that stuff.
It's plus 5 because there's 3 oxygen.
Yeah, it's +5 because there's 3 oxygen.
So oxygen is 2. So
Oxygen is 2 minus, but
This is this. The charge.
Oh, okay.
Yeah, that's right.
so these are because learning structure, composition and properties is a multi-pronged approach. We have to just memorize some things. Things you memorize is chlorine in the +5 and +7 is not happy. Even chlorine in the 0 is not happy. Because even when chlorine's in the 0, this is what we call 0 because there's no charge, it's not an ion. But, is compared to chlorine. Let's say I ran out, I love chloride and salt on the French fries. I ran out of chloride, I'm gonna just grab a bottle of chlorine gas and then spray it on my fries and add that taste to it. Is that gonna work? No, not at all, because chlorine, even in the 0 is unhappy, and in the +5 it's terribly unhappy, and in the +7 it's terribly, terribly unhappy. But in the -1, it's happy. So this kind of error that I saw on this slide is a grave error. This kind of error might give people the impression that chloride, it's no big deal. It's the same thing, chlorate and chloride, right? No big deal. Same thing.
So that's
No, it's not. However, why did I say chlorine? Because chlorine and chloride are 2 totally different things. Chlorine and chloride are 2 totally different things, but the easiest thing to do is just say grams of the element chlorine, whatever the form is. It could be chloride. Like the chlorinating solution for the swimming pool did not consist of. Do you know what chlorinating solution consists of? If you go to, let's say, Lowe's or Home Depot and buy some chlorinating solution for whatever swimming pool that you have, it consists of this compound, a solution of this dissolved in water. Do you know what that is?
sodium hypo.
Sodium
hypo, you're right, sodium hypochlorite. Sodium hypochlorite is what this is. AKA, what do we call sodium hypochlorite?
So,
Household chemical name, except bleach. This is a bleach. But normally when you buy bleach for the house, it's very low percentage, bleach. But for a swimming pool, you get up to like 30% bleach, which is pretty high. The bleach versus chlorine, bleach is less happy than chlorine. Chlorine has a bleaching action too, but bleach is less happy. So when we look at this, what the charge on chlorine is and hypochlorite on it? This is +1. Plus. And so even for the chlorinating, remember the chlorinating, the swimming pool thing? We just called this chlorine. We didn't call it chlorine plus, we didn't call it chlorine minus, we just called it the element chlorine. Whatever the charge is, I don't care what the charge is, this is how much chlorine it has. Well, the chloride probably doesn't impart much taste. It's the sodium in sodium chloride, and it makes a huge difference. The charge, let me just tell you, the charge makes an enormous difference because all of these are chlorine, right? But if we have a -1 charge, it's happy, stable, unreactive. Is your table saw going to explode on your table and cause massive destruction? No, but perchlorate could, And so charge is so important. So, for example, this we call like the element sodium. This we call sodium ion. Now, which one do you think is more stable, sodium ion or sodium metal? Sodium metal is more stable? Okay, then what we want to do is, sodium metal is more stable. Let's look at sodium surplus. All right. I think the U.S. Army or something had excess sodium metal, and so this is sodium metal, and they have too much, so they're going to dispose of it.
20,000 pounds of highly dangerous metallic sodium head for destruction in Lake Lenoir, Washington. The government surface chemical ignites and explodes when wet. The alkali lake is devoid of fish and forms an admirable disposal spot. A 3,500-pound container of sodium hurtles into the lake and crashes through a foot of ice. As the water seeps in, smoke rises through a series of muffled explosions. The acrid clouds billow several thousand feet over the steep sides of the lake. Disposal of the chemical by the War Assets Administration is made necessary because no public carrier will accept it for transportation to a purchaser. One after another, with varying effects, the containers go up with spectacular results as water and sodium meet. A once lethal war chemical becomes a peacetime pyrotechnic display.
Okay, so if I ask on a test, which one's more stable, sodium metal or sodium ion? Yeah, well, a lot of people say, well, let me Google that or let me see. Yeah. But you do it once, you figure it out, and you'll see it.
Depends on which, how you're using same
Yeah, that's true. Sodium is plenty stable as long as you don't have something to react it with. You know, sodium metal, no problem. Problem is, can you mine sodium metal out of the ground? No, you aren't going to find it. Well, we still have time left, right? 2 minutes? 1 minute? Well, that pretty much concludes chapter 7. So we're going to start with chapter 8. And this kind of stuff, you know, this reactivity stuff deals with chemical reactions or chemical properties. And so we're going to start memorizing a whole bunch of chemical properties, but there's patterns to it, so it's not all straight memorization. But initially, you're going to have to memorize a lot of information. This is like organic chemistry. A lot of people say it's a lot of it is a lot of memorization. But after you memorize a certain amount of basic knowledge, then you have enough that you can figure things out. And so we need to get to that. We need to get to that hump. We need to get over that hump. The problem is people don't get enough basic information down, and they never make it over the hump. You know, they're always falling back down to the other side. So just to forewarn you, we're going to have some memorization to do.